students, so let's start with the explanation of the chapter Combustion and Flame from the part where we left. So in the last class we were discussing about how can we control fire. We had discussed how carbon dioxide can serve as a very good fire extinguisher in case of electric appliances. We had also discussed about the flame, okay, the structure of the flame, right? So we'll discuss more about the structure of the flame in detail in this video today. And so we were in this slide in the last class, okay. What happens when we hold a thin long copper wire inside the flame for about 30 seconds? So when you hold something inside the flame, as I told you, inside the flame it is not that hot, but the outermost zone of the flame is hot. But metals, since they are very good conductors of electricity, so if you hold a copper wire, then it will become red hot, okay. So the substances which vaporize during burning give flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames, okay. So some substances, as I told you, they burn with flames, some they do not, okay. Like kerosene oil, when you burn, definitely it will vaporize and it will burn with a flame, okay. Molten wax also burns with a flame because we know candle is made up of wax, okay. But charcoal or coal, okay, it does not vaporize and so it does not produce a flame. So charcoal, they do not vaporize during burning, okay. So that is why they don't produce a flame. And when a candle flame is steady, introduce a clean glass plate or slide into the luminous zone of the flame. Hold it there with a pair of tongs for about 30 seconds and then remove it. What you will find that there will be a circular blackish ring formed. Okay. I told you to try that out. I hope you have tried out. If you haven't tried out, you can try it out today also. So note that the portion of the copper wire just outside the flame gets red hot. Does it indicate that the non-luminous zone of the flame has a high temperature? Yes. Non-luminous zone is the outermost zone of the flame. Okay. So the copper wire, if you put it inside the flame, the tip of the wire will not become red hot, but the outer part of the wire will become red hot because the outer part, it comes under the non-luminous zone of the flame, okay. So in fact, this is the hottest part of the flame. I'll show you. Goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. Now goldsmiths, we know they deal with gold and silver, okay. So whenever they need to melt gold and silver, they will use the outermost part of the flame, not the innermost part. Okay, so the outermost part or the non-luminous zone, that is the hottest part of the flame. Now we come to fuel. So the sources of heat energy for domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. Okay. So what are fuels? Fuels are basically the sources of heat energy for domestic and industrial purposes. Okay. So anything that gives you heat, like wood, okay, it gives you heat if you burn it, right? Petrol, when you burn it, it will give you heat, okay. So anything, any substance that burns easily and gives off heat and light, that is called fuel, okay. So these substances are called fuels. A good fuel is one which is readily available. Very, very important. What are the characteristics of a good fuel? Number one is it should be readily available. That means you should easily get that, okay. It should be cheap. That is the second part. It burns easily in air at a moderate rate. It should burn easily, okay. It should produce a large amount of heat. It does not leave behind any undesirable substances, okay. Anything that is poisonous, it should not leave behind, okay. So there is probably no fuel that could be considered as an ideal fuel. So these are the characteristics of an ideal fuel. But when you look at those characteristics, can you tell that is it possible for you to get an ideal fuel? No. Why? Because suppose take the example of petrol. Petrol is readily available, but it will get exhausted if you use it too much. It is cheap. Is it cheap? No. Petrol prices are hiking like anything. So it is not cheap. So you cannot consider it to be an ideal fuel. Okay. Now if you consider wood, yes, wood is readily available. It is cheap. It burns easily. It produces large amount of heat. But it does not leave behind undesirable substances. Wood leaves behind ash. Okay, sometimes it gets converted to fly ash, which is very dangerous. So people that have asthma or bronchitis, if they inhale that ash, then very dangerous, it can cause problems in their respiratory system. Okay, so that is why you cannot consider even wood as a ideal fuel. So there is nothing called as an ideal fuel, okay, because it will not fulfill all the characteristics. Okay. Yeah, so this is the thing that I was talking about. Suppose this is a copper wire. If you hold it with a pair of tongs, put it inside the flame, inner part will not become hot, but the outer part will become red hot, because this part of the flame, the outer part, this part, the non-luminous zone of the flame, this part is the hottest part. So when you put an agarbatti or anything inside the flame, it will not burn. You have to put it just outside the flame, just outer part of the flame. That is the non-luminous zone of the flame. Now this is what I was talking about. When you take a candle and you put a slide or anything made up of glass on top of it, you will find a circular blackish ring is going to form here. Okay, so what is that circular blackish ring? That is the unburnt carbon particles. Okay, that is the unburnt carbon particles. Okay, because flame, it produces, candle flame basically, it produces unburnt carbon particles. Okay, so that is not completely burnt, so it will deposit as a blackish ring. So you can see that if you want. Now this diagram is very important, and this is what I asked you to draw. Okay, if you remember. So please submit, those who haven't submitted this diagram. So now this is the different zones of the flame. You see, this is the outer zone. Can you see this bluish part? Yes, so this is the outer zone. Here complete combustion occurs. That means complete burning will occur in this part. Okay, anything you burn, you just put it in this part, it will burn completely. Okay, middle zone, this is the yellow part. The yellow part is the middle zone. This is the zone of partial combustion. Partial. That means it will not burn completely. Like carbon particles, they burn in this part of the flame. That is why you get the unburnt carbon particles. Okay, because here there will be partial combustion or partial burning. Okay, innermost zone of the unburnt wax vapors is black. This is the innermost zone. Here black color is not that visible, but this part, it will be dark blue or blackish in color. Okay, so here there will be unburnt wax vapors, something that will not burn at all. So in the innermost zone of the flame, the substances will not burn at all. That is why it is written here, unburnt wax vapors. So here you will have unburnt wax vapors. Is it clear? So if you put the agarbatti here in the innermost zone of the flame, will it burn? No, it will definitely not burn. So you have to put the agarbatti here in the outermost zone of the flame. Then only it is going to burn. Okay, is it clear? So these are the different zones of the candle flame. So remember, hottest part is the outermost zone. That is the hottest part, the blue part. Okay, and that is also called non-luminous zone. Moderately hot is the middle zone. Okay, and the least hot or the luminous zone is the innermost zone. Okay, that is the least hot, and there the substances will not burn easily. Is it clear? So whenever you burn an agarbatti, make sure you put the agarbatti in the outermost zone of the flame. Then it will burn fast. If you put it inside, it will take time in burning, or it might not burn. Okay, so we'll continue with the explanation in the next video. Thank you.